Today we're going to focus on different things that we can do in order to manipulate an equation that we're trying to solve before we start solving for our variable in order to make it easier. So we're going to do some optional things that maybe would help you go ahead and make the problem easier to solve. So let's go ahead and jump on in. So we are working on making equations easier. And we're going to go ahead and look at a number of different ways that we can do this. Okay, so let's go ahead and look at our first example, example 1. So we have an equation 2x plus 3.5 is equal to 8.5. Okay, and one thing that we can do is we see, of course, that there are decimals. And especially if we don't have a calculator with us, decimals can be a little bit difficult to deal with. And so what we can do as a technique to get rid of those decimals, we can multiply or divide the same number to every term on both sides. So what that means is if I have a very simple one, like I have 0.5 for both of these, what I can do is if I multiply everything by 2, that makes a 0.5 go away. So I'm going to go ahead and put parentheses around every single term, and I'm going to double it. I'm going to multiply every single term on both sides by 2. Now, when I do this, I have to make sure that it is every single term on both sides. So I can't just do it to the decimals. I have to include my 2x as well. And now I'm going to go ahead and multiply that out. 2 times 2x is 4x. 2 times 3.5 is positive 7. And 2 times 8.5 is 17. So as you can tell, my new equation here is much simpler to solve. And then I'm just going to go ahead and solve normally. I'm going to subtract 7 from both sides, do the opposite operation of adding 7. And I'm left with 4x is equal to 10. And then I'm going to go ahead and divide both sides by 4. And so my answer, x is equal to 2.5. Okay. So that's one of our techniques that we can do, is we can go ahead and multiply something both terms. Let's go ahead and take a look at an example 2 where I could also use this technique, but potentially divide instead of multiply. So if I have 1,000 x plus 1,600 is equal to 3,600. As you can see in each one of these, I have 2 extra zeros. So what that means is I can divide every term on both sides by 100, right? So basically what that does is that takes both of those zeros off. And so when I divide every single thing by both sides there, I end up with 10x plus 16 is equal to 36. And as you can see, because my numbers are smaller, it is much easier to solve, and I can solve it without a calculator now. So I'm going to subtract 16 from both sides, and I get 10x is equal to 20. Divide both sides by 10, and x is equal to 2. Okay. Now, I'm going to show you a third example here for a different kind. And we're going to go into more detail of how this one works. But this one is called fraction busting. And like I said, we're going to write this down a second time where we're going to go over more examples of it. But our first step for fraction busting is to find the common denominator. Step number 2 is multiply all terms on both sides by the common denominator. And then our third step is to simplify, which is basically going to be a cross cancel. Okay, and we're going to do one example today. Like I said, we are going to go in more detail for this on our next class. So example 3, let's say that I have 2/5 x plus 3/5 is equal to 17/5. So this is a very simple one that we're starting with here. But basically, I see that I already have a common denominator. And so I'm going to multiply every single term on both sides by 5. Okay, and basically what that does is 5 divided by 5 is 1, and 1 times 2x is 2x. 5 divided by 5 is 1, and 1 times 3 is positive 3, and that's equal to 5 divided by 5 is 1, and 1 times 17 is 17. So now we're going to solve, subtract 3 from both sides. 2x is equal to 14. Divide both sides by 2, and x is equal to 7. So that's a very simple version of it. And we're going to do ones that are a little bit more difficult in our next class. Okay, so that is a second technique. Okay, our next one here is it is how to solve your problem when there is a variable as an exponent. I call it, and this is just really silly, magic unicorn. Okay, step number 1 for magic unicorn is make the bases the same. And step number 2 for magic unicorn, move this down a little bit. Step number 2 for magic unicorn is to ignore the bases. Step number 3 is set the exponents equal to each other. Okay, and then of course, final step 4 is to solve. Okay, so we're going to go ahead and do a couple examples here and talk about why I call it magic unicorn. And really, there is no good reason. No one calls this magic unicorn. It's not a real term. It's not a real It's not a real technique. So here's our example 4. We have 2 to the x plus 6 is equal to 2 to the 5th power. Okay. Now, step number 1 is make the bases the same. They already are. So when the bases are the same, it makes this magic unicorn really happy. And when the magic unicorn gets really happy, it has a magic power and it starts to get glitter everywhere. Glitter goes all over. And the magic unicorn's horn goes through, splits the bases open, and they disappear. So what we have here is disappeared numbers. So we're ignoring them, thanks to the magic unicorn getting very excited that the bases were the same. And so now what we have left is simply our exponents. So we're going to set those equal to each other. X plus 6 is equal to 5. And then we're just going to solve normally. So we're going to subtract 6 from both sides, and x is equal to -1. Now, as we're looking here, here I have 2 to the -1 plus 6, which is 2 to the 5th power. 2 to the 5th power is 2 times 2 is 4, 8, 16, 32. So 2 to the 5th power is 32, and over here I have 2 to the 5th power. So to make these two equal to each other, it makes sense that x is -1, because -1 plus 6 is 5, and we want them to be equal. Now, once again, we can only do this if the bases are the same. So let's try an example where we need to change the bases to make them the same. So here we have 2 to the x plus 3 is equal to 4 to the 5th power. So as you can see, the bases are not the same. And so that means we can't ignore them yet. We have to make them the same. Now, the way that we make them the same is we go ahead and we take a look at the smaller one. Our smaller base here is 2. And I ask myself, is there any way I can use 2 as a base with a power and turn it into a 4? And we know that 2 squared is the same as 4. So we're going to rewrite it. Here we have our 2 to the x plus 3. And we're going to write our 4 as 2 squared. And then whatever is already there, we're going to put next to in a set of parentheses. So we've turned our 4 to the 5th power into 2 to the 2 times 5 power. Now, those are the same. And so our magic unicorn gets glitter, super excited, and those are going to go away. So what we have remaining here is x plus 3 is equal to 2 times 5 is 10. I'm going to subtract 3 from both sides, and so x is equal to 7. So that's telling me that 2 to the 7 plus 3, 2 to the 10th, is equal to 4 to the 5th. So we're going to go ahead and show us that that is indeed the truth. So we have on our left-hand side 2 to the 7 plus 3, which is 10th power, and we have determined that's equal to 4 to the 5th power. And they both are, so that means that we got our variable for our x correct. Okay, let's go ahead and try one more of those, and this is as hard as it gets because you're actually going to switch both of the bases. So our example 6 is 9 to the x power is equal to 27 to the 8th power. So in this case, I know that my smallest number 9 squared is 81. And so I know I can't use 27. So I'm looking at ways that I can make a 9 and a 27. And I know that 9 is 3 squared. 3 squared is 9. But if I take 3 to the 3rd power, that's going to be 27. So we're going to rewrite both of them. So that's going to be 3 squared with my x in parentheses is equal to 3 to the 3rd power with my 8 in parentheses. And so we have 3 to the 2x is equal to 3 to the 24th. Now, once again, our bases are the same, and so magic unicorn basically means that we can go ahead and once they're the same, we can ignore those. What we have left is 2x is equal to 24, and then we can go ahead and divide both sides by 2, and our final answer here, x is equal to 12. Okay, so what we're saying is 9 to the 12th power is the same as 27 to the 8th power. So we're just going to double check our work here. Here we go. So we have, for our first one, 9, and then we decided that x was 12. And then we have 27 to the 8th power. And as you can see, they're the same. Now, this is a really big number, 2.8 times 10 to the 11th power, but we're just verifying that they are the same. If I had missed the problem, for example, maybe I thought the answer was 11, I could see that I would get 2 different answers, and I would know that I need to go ahead and try again. Okay, so ladies and gentlemen, these are a couple techniques of how to go ahead and make some equations a little bit easier. Multiplying the same number by everything on both sides, fraction busting, and then when we have our exponent, our variable in an exponent, then we can go ahead and use the magic unicorn technique, which is making the bases the same and then simply setting our exponents equal to each other. Let's go ahead and practice.